Welcome to the unit on scale drawings. Today you will learn about scaled copies and scale factor and the connection between the two. So let's start with a scaled copy. Here we have a trapezoid, and a scaled copy would be where we have another trapezoid the very same size, or a trapezoid which is smaller, which has been reduced by the same amount all round. So in this smaller trapezoid here, all the dimensions have been halved. And in this larger trapezoid here, all of the dimensions have been multiplied by 1 1/3 to give you a scaled copy. So the key thing is all sides have to be multiplied by the same number to give you your copy. So to create a scaled copy, as I just mentioned, you multiply all sides of the original shape by the same number, and this number is called the scale factor. So let's look at this example, polygon 1. Let's look at AB. It has a side length of 3. Multiply it by 2, you get a side length of 6 here. Taking the base, 3.2, multiply it by 2, you get a side length of 6.4. Multiply 2 times 2, you get 4, and so on all the ways around. That's how scale factor is used to create a scaled copy. So let's look at these letter F's here and try to decide which of these are scaled copies and which are not. And I suggest you pause the video and have a look at them and try to decide for yourself before proceeding with the tutorial. So here I've marked the F's which are copies, scaled copies of the original. So let's start with drawing 2. All sides of the original F have been multiplied by 2 to double the length. So 2 times 2 is 4. And here we have a length of 4. The vertical line is 4 long. 4 times 2 is 8. And the line across here, 1 times 2 is 2. And if we look at drawing 7 over here, the original side lengths were all multiplied by 3. So 2 times 3 is 6. 4 times 3 is 12. And 1 times 3 is 3. And in the case of drawing 1, all sides have been multiplied by 1.5. So some of the other drawings, some of the other copies of the letter F look like they could be scaled copies also. So let's look at why they're not. Let's look at drawing 3. This one's actually kind of obvious. It's wider. The top is doubled, but the side here is not doubled. And the line across the middle is multiplied by 3. So all 3 lines are multiplied by different numbers. So definitely not a scaled copy. And 4 is not a scaled copy. It's totally different shape. But 5 looks like it could be, and it's not. So if we examine it closely, we can see that the top line of the original F is too long, and this is 3, so it's been multiplied by 1 1/2. And 4 times 1 1/2 would give me 6. But the line across here, this is 1, this is not 1 1/2 long, it's been multiplied by 2. So you've got 2 different numbers multiplying these. And similarly with drawing 6, the line across the middle has been multiplied by 1 and the others have been halved. So again, different numbers. So these are not scaled copies. What if you're given a copy and an original figure and are asked to calculate the scale factor? Here we have trapezoid B, which has been enlarged to produce A. So the first thing to do is to set up the problem the length of the base of the scaled copy, the length of this one, which is the copy, divided by the length of the original figure, the same side of the original figure. So it's 7.8 divided by 2.6, and the scale factor is 3. So to go back to the letter F's again and the scale factors. So drawing 1, the scale factor is 1.5 because all sides have been multiplied by 1.5. Drawing 2, the scale factor is 2 because all sides have been multiplied by 2. And drawing 7, the scale factor is 3 because all sides have been multiplied by 3. So I'd like you to pause the tutorial now and decide which of these is a scaled copy of the original A, and write in your notes explaining your thinking. So let's look at corresponding parts of scaled copies and original figures. So when a part of an original figure and a scaled copy match up, they're the corresponding parts. So for example, here vertex B corresponds to vertex E. Line segment AC here, this side of the triangle, matches this side, so they're corresponding. And angle ACB corresponds to angle DFE. And here we can see corresponding angles in two triangles where one is a scaled copy of the other. And something to note here, this first triangle is ABC, and we will describe the second one in the same order, RQP, because R corresponds to A, Q corresponds to B, and P corresponds to C. We wouldn't say PQR corresponds to ABC because then you wouldn't be naming them in the same order. So angle R corresponds to angle A, so they're both 50 degrees. Q corresponds to B, you can see they're both 100 degrees, and P corresponds to C, both 30 degrees. So all angles, all corresponding angles are congruent, meaning they measure the same. So let's look at this example and try and figure out what the missing angle measures are. So EFGH is a scaled copy of ABCD. What's the measure of angle E? So let's look at the corresponding angle. E corresponds to A, and A is 110 degrees, so measure E measures 110 degrees. And then what's the measure of angle B? B corresponds to angle F, and this mark here means it's a right angle, which is 90 degrees, so angle B measures 90 degrees. So the characteristics of scaled copies. The shapes are the same. Every line segment in the original figure is multiplied by the same number, the same scale factor, to calculate the lengths of the lines in the scaled copy. Because they're all multiplied by the same number, this means that the line segments in the scaled copy are proportional to the line segments in the original figure. And very importantly, the angle measures are congruent. So here are some questions for you to work on. I want you to pause the video and answer these questions in your notebook. So recalling today's goals, you can tell if one figure is a scaled copy of another. So looking at this example here, all angle measures, all corresponding angle measures are congruent, and it doesn't show the side lengths here, but the sides of ABC have been multiplied by the same scale factor to get RQP. And you can describe, the second goal was describing what the scale factor has to do with a scaled copy, and the scale factor is the number that you multiply the side lengths by to get the side lengths of the scaled copy. So that was today's lesson. Thank you.